Let's add and subtract radicals. So number 12. Let's start by first not adding and subtracting, but simplifying radicals first. So that is not the right tool. Number 12 on page 93. What is the cube root of 16? Well, we know that the 2 to the 4th is 16, right? So 2 to the 4th power is 16. That we know. What's 2 to the 3rd power? 2 to the 3rd power is 8. And we can't take away a 3 from this because 3 to the 3rd power is 27, which is above what we're trying to do. So we're going to have to take out a 2 here. So 8 is the cube of 2. So we can actually separate this into the cube root of 8 times, multiplied by, the cube root of 2. Because this just combines to be the cube root of 8 times 2. And that's just 16. So going down from here, what's the cube root of 8? Well, it's just 2 as we've seen right here. And then the cube root of 2 is just left over. So that's our answer for number 12. Fair enough. Alright, what about number 20? Square root of a to the 5th over 2. If we have the square root of some kind of a over b, it's equal to the square root of a divided by the square root of b. So we can separate this into the square root of a to the 5th over the square root of a. Just 2. So what can we split a to the 5th to? Well, recall that a to the 4th times a is equal to a to the 5th, and the square root of a to the 4th, as you all might know, is a squared. With this thought process in mind, we can convert this into square root of a to the 4th times just a over the square root of 2. And this can further be simplified by a squared times a over rad 2. We're not asked to simplify the denominators yet. However, I'm going to go over rationalizing the denominator in this video, just so that you guys can learn it ahead of time. So we don't like irrational numbers such as the rad 2 in the denominator. It's just not clean. To make it clean, we need to rationalize the denominator, which is to say, multiply the denominator by itself, which means we're going to multiply the numerator by rad 2 and the denominator by rad 2. Now what does this become? Well, we've got an a squared rad 2a up top here, and on the bottom we have rad 2 times rad 2, which is rad 4, right? This is rad 4, which becomes simply 2. So there, we've rationalized our denominator, and now it's over 2, which is nice. And that could be viewed as our final answer. For our next question, we're asked, this is number 34. For number 34, we're asked, this is on page 94 now, I believe. 128 x squared. So we obviously don't know the largest square that goes into 128 off the top of our heads. If you wanted to, you could continuously divide this by smaller squares that you might know, such as 16 or 4, until we get the answer. However, I do know that 64 times 2 is indeed 128, and 64 is a perfect squared. 8 squared is equal to 64. With this knowledge, I can separate this into 64 times 2, and of course that x squared. Whoops. What is that? So now the 64 becomes an 8. This the square root of x squared is just x, and the square root of 2 is left out. So that's our answer. 8x rad 2. I believe we have one more simplifying problem left. I believe we have one more simplifying problem left. The area of a pool is 5x squared y to the fourth pi square meters. So we have a circular pool here, and the area inside this pool is 5x squared y fourth pi square meters. What is the radius? Okay. Recall that pi r squared is equal to the area of any circle. We're given the area as 5x squared y to the fourth pi is equal to pi r squared. When we divide a pi from both sides, we can cancel out a pi here and here. Therefore, we are simply left with 5x squared y to the fourth is equal to r squared. Taking the square root of both sides, as shown here, will result in r is equal to the square root 5x squared y to the fourth. Now how can we do this? We'll separate the 5, we'll separate the x squared, and we'll separate the and the y to the fourth. Taken separately, this becomes r equals the square root of x squared is x, the square root of y to the fourth is y squared, and the rad 5 is left over. Thus, our radius for this circle is just xy squared rad 5. That's it for that section. Now let's get into adding and subtracting some radicals. This is number 6 on page 97. 5 rad 7 minus rad 7. If we have sum A rad B minus C rad B, we can just do that. So it becomes, we can essentially take that rad b out. So it becomes that. So what I can do here is you can always put that coefficient of 1 in front of that rad 7. And when we take that rad 7 out, we get a 5 minus 1 times rad 7, and we're left with 4 rad 7. This is the mechanic for adding and subtracting radicals. Basically, if you have the same radical in front of the coefficient here, you can just subtract those coefficients and the radical is left at the end. So 2 rad A minus rad A would be simply rad A, is what I'm saying. And, of course, rad A plus rad A is equal to 2 rad A. So with that knowledge, let's tackle more questions. Number 8 says 3 rad 5y minus rad 20y. First, we need to separate this 20y into 4 and 5y. Why this particular combination? Because we need to subtract 5y's, right? 5y is going to be our common radical that we need to subtract from. So if we separate 20y into 4 and 5y, this subtraction problem now becomes subtractable because it becomes 5y, 3 rad 5y minus 2, because the square root of 4 is 2, times rad 5y. And now the answer, as you can see, simply becomes rad 5y. That was number 8. Number 14 here says 14 is x times rad 32x plus rad 128 times x to the third. Alright, let's see what we can do here. Well, this 32 is simplifiable. It's simplifiable to 4 times 2x, right? And this plus thing, this separates into 64x squared times 2x. So this just becomes 4x rad 2x plus 8x rad 2x. Now that we've simplified everything, we can just add straight. So our final answer is 12x rad 2x. Alright. Number 28. Cube root of 2 minus the cube root of 16. We need to simplify this cube root of 16 into the cube root of 8 times the cube root of 2. Doing so gets us cube root of 2 minus, just 2 cube root of 2. This becomes a negative cube root of 2 as our final answer. I draw kind of slanted. It's because I'm far away. Number 32. Just the regular 100y minus 25y. Alright, this can be separated into 100y. This can be separated into 25y. This becomes 10 rad y minus 5 rad y. So our final answer is 5 rad y. I feel like I need a color change, so I will switch to a more purplish color. For 36, we have rad 4ab squared minus ab squared. All we need to do here is take out the 4 here, and we're left with 2 rad ab squared minus ab squared. And we're left with an ab squared. Of course, this also simplifies to b rad a. You could also do it this way. You could actually take out that b squared before everything else, so you're left with a 4, I'm sorry, not a 4, you'd be left with a 2b rad a minus b rad a, and you would be left with a b rad a. You could do it that way as well. I just simply intuitively saw this, that both these had an ab squared in common, so if I just took out that 4, I could just subtract. That's what I intuitively thought, but you could also do it the second way. Number 40 is on the other page. It's on page 98. They're telling us to solve and check each equation. 12y plus rad 32 is equal to the rad of 200. Okay, well, if we subtract rad 32, we now need to simplify this, obviously. So what does this become? Well, this 200 simplifies into 10 rad 2 minus a 4 rad 2. You can do those computations on your own if you'd like. So 12y would be equal to 6 rad 2. And now when we take the square of both, you get 144y squared is equal to 36 times 2, which is equal to 72. And we get y squared is equal to 72 over 144. Taking the square root of both sides, let's get rid of some real estate here. We're left with a 72 over 144. This is just 6 rad 2 over 12. Final answer. Alright, so that's the value of y. 6 rad 2 over 12. Number 44. The length of each of the two congruent sides of an isosceles triangle is rad 500 feet, and the length of the third side is rad 45 feet. What's the perimeter of the triangle? The length? It's an isosceles. It doesn't say it's a right triangle, that's why. So we have an isosceles triangle, right? And two of its sides are rad 500, rad 500. This side is rad 45. We need to add all of this up because we're asked for the perimeter. So how do we do that? Well, we just add everything up. 2 times 500 plus rad 45 is equal to what? Well, this simplifies to 2 times 10 rad 5 plus 3 rad 5. So this is 20 rad 5 plus 3 rad 5. So the perimeter would be 23 rad 5. Okay, that's simple. I believe this is the final one now, 46. 46 says length of an isosceles right triangle. Each leg is rad of 98 inches. What is the length of the hypotenuse? As you can see, this is a 45, 45, 90 triangle. In 45, 45, 90 triangles, if these sides are S, the hypotenuse will be S rad squared. Therefore, it is safe to assume that our x here is just going to be rad 98 times rad 2. And what is that? Well, that's 90 times 2 plus 8 times 2. 180 plus 16 is 196. It is going to be rad of 196. Rad 196 is going to be our hypotenuse. And how do we simplify that? Let's think that through a bit. What is the rad of 196? Well, before we do that, let's divide 16 into 196 and see if we get anything interesting. Okay, looks like we can't do that. How about 4 going into 196? 16, 36 is 9. Alright, so we do get from here, we get a 2 rad 49. And then that just becomes 2 times 7, which is 14. So our x here is most likely going to be 14. Second part tells us to find the perimeter. Alright, 2 rad 98 plus 14. What's 98? 98 is 40 times 9 times 2, right? Well, it's going to be 14 rad 2 plus 14. And that's our final answer. That's our perimeter. Alright, so we're done here. Well, alright, thanks for watching.